Okay, so we are going to learn about the activity series. Now, the activity series is only used for single replacement reactions. That is it. So what we want to do is we want to look at the 4 reactions that were part of the single replacement lab. If you have not watched the single replacement lab video yet or have not done the lab, please watch that first before you do this. Now, from the lab, we saw a reaction occur for 1, 2, and 4, but we saw no reaction for number 3. So what we want to do is figure out why. So what we want to do first, always, for a single replacement reaction is create our products. And we know in single replacement reactions, we have to figure out whether the element that's by itself has a plus charge or a negative charge. So here we have zinc, aluminum, tin, and zinc. And all of them are metals, so in the ion form, they would all have plus charges. So that means that we are switching spots with the element in the compound that has that positive charge, the cation. So zinc and copper are going to switch places, aluminum and copper are going to switch places, tin and sodium are going to switch places, and zinc and hydrogen are going to switch places. So we're going to go ahead and kick those out so that copper is now by itself, and zinc is now with sulfate. Remember, whenever we form a new compound, we have to check those charges. Zinc has a +2 charge, sulfate has a -2 charge, so it's already neutral. Then aluminum's kicking out copper, so we have AlCl plus copper is now kicked out. Again, we have to check our charges. We know by looking at the periodic table that aluminum has a +3 charge, chloride has a -1 charge, so it's going to become AlCl3. Tin is going to kick out sodium, so sodium is now by itself, and tin is with Cl. We learned from the lab that tin in this case had a +2 charge, so we're going to go ahead and put a 2 right there. And then hydrogen is going to be kicked out, and since hydrogen is a diatomic element, it needs to have a 2 subscripts when it's by itself, and zinc is going to pair up with chlorine. Zinc has a +2 charge, chloride has a -1 charge, so it becomes ZnCl2. Now you can go ahead and balance these reactions, and that is important to do, but not the point of this video. So please make sure you do balance these charges. The point of this video is looking at this activity series. What we want to do is we want to say, okay, what similarities were there when we looked at the reactions that did occur? So let's look at just the metals that were part of it. We had copper, which is down here, and we have zinc, which is up here. Notice how zinc is higher up on the activity series than copper. Let's see if the same thing happens for one of them that also occurred. Here we have aluminum that's by itself, and here we have copper. Notice how the element that's by itself is also on top of the element that's in the compound. Now let's look at one of them that did not occur. So sodium and tin. Sodium is up here, and that was in the compound, and tin is all the way down here. So what we can learn from this is that the reaction will only occur if the element that's by itself, the element that is by itself is higher up on the activity series. So what we need to know, higher up on the activity series is more reactive. So if the element that's by itself is higher up, it will replace anything below it. If the element that's by itself is lower, then it will not replace, and we would have no reaction. So we put a double slash through that reaction arrow and write no RXN above it. This is how we use the activity series.